Hi, good morning, everyone. I think I need to be here, right? Okay. So my name is Adil Baghir. I'm working for A10 Networks as a head of solutions for the telco and service provider accounts. So I'm really excited to be to participate today in UKNOF as my first participation in the UK since I moved or relocated to the UK late 2020. So our topic for today is defending DNS services from multi-vector DDoS attacks. So we got a large and kind of big topic that I need to cover in 15 minutes, including Q&A. But I'll do my best to stick to the time. So when we talk about DDoS is a very wide and generic term. But this discussion or topic will be very specific about DNS. So DNS servers are very critical infrastructure, right, for service provider and enterprises. And they are mainly used to enable their internet users to access the internet. It is known as the phone book of the internet. The DNS has the three, as we can see here, a tree-structured database. I will not spend much time on this slide since most of you are sure familiar with the DNS structure. So DNS attacks have been evolving, and it's becoming one of the top targets for network and DDoS attacks. Here we can see some snapshots from some of the recent DDoS or DNS-based DDoS attacks that has an impact on certain service provider and enterprises. We also see here the top 10 DNS-based attacks showing the different type of attacks. This is from efficient IB threat DNS report showing the different type of attacks, including DNS phishing, DNS tunneling, DNS hijacking, and other type of DNS-based attacks. Some of you might recall the Dime DNS in 2016 or 2017 when the Dime DNS or the Mirai botnet leveraged the compromised IoT devices. And these infected IoT devices were used to generate a massive DNS-based attack targeting the Dime DNS. The impact was really massive, and that brought down some of the largest websites in the US and Europe. And since that time, we are seeing a lot of DNS-based attacks, and it keep evolving, and of course, it's becoming very frequent. So when we talk about IoT, people may think it's a kind of a special IoT devices, industrial use cases, but that's not the case. When we talk about IoT, if you log in today to your broadband modem and see the number of connected devices to your Wi-Fi, I'm sure you will be surprised with the number of IoT devices or devices connected to the Wi-Fi. And this is just an example we have here in this picture. Most of these IoT devices have very limited computing resources, and typically they are not securely coded. Attackers are using these kind of compromised devices or insecure devices to generate a lot of or massive DDoS attacks and DNS specific targeting the service provider and enterprises DNS infrastructure. This kind of massive attacks is impacting the DNS infrastructure, and of course, as we know, if the DNS is vulnerable and impacted, then the impact on the network application could be massive. So since we talked about the IoT, and here we will have, there are two types of DNS-based DDoS attacks. And attackers are using this kind of DDoS attack strategies to attack the infrastructure or DNS infrastructure of the service provider and enterprises. So we're talking about general attacks or network-based attacks and DNS-specific attacks. The reason the DNS is also vulnerable to DNS or general attacks because DNS listen and serve other protocols like TCP, UDP, ICMP floods, right? Including layer 3, layer 4 packet anomalies. This kind of attacks is also impacting the DNS infrastructure. The other type of attacks is a DNS-specific attacks. So we're talking about DNS reflection, DNS amplification, DNS protocol anomaly, repetitive any queries. It doesn't have to be any, of course, any let's say, DNS-based query type. So it could be non-existing domain, DNS any, and any other DNS query type attacks. Again, as we can see here, DDoS of things or IoT of things. And even if we look at most of the recent DNS-based attacks, we will find the most used weapons are IoT or compromised IoT devices. Now, as we can see here, the victim can be either recursive DNS or authoritative DNS. We'll try to talk more about this in the coming slides. Now, when we talk about DNS defense strategies, unfortunately, defending DNS is not an easy, and it's a complicated process, right? So it is not an easy just to block DNS because the way DNS is designed, it's designed to host public information and publish this information to the internet, right? Which is the user, domain names and the IP addresses. So blocking DNS is not a solution, and that's why it's a complicated process. So we have two types of defense strategies here, from DNS firewall and DNS DDoS defense, and we have the encrypt DNS. When it comes to DNS DDoS defense, we talk about mitigating against DNS-based volumetric and DDoS attacks, DNS protocol validation, recursive and authoritative DNS caching that would help to scale the DNS infrastructure, zero-day attack protection, threat intelligence, and of course security. When it comes to security, analytics and reporting is always a key. Encrypting DNS, we are talking about DOH or DNS over HTTPS, DNS over TLS to enable user privacy and prevent interception. Although DNSSEC does not provide encryption here, it's mainly used for authentication, but that's almost help to mitigate any DNS spoofing. So we'll try to talk more about how we can defend these the type of defense techniques. Again, we talked about the general attacks and DNS-specific attacks. So we have the packet anomalies, TCP, UDP, ICMP flood mitigations, spoofed source IP and reflection attack mitigation, random query names, water torture attack. I just wanted to emphasize on the DNS water torture attack that was used actually during the Dying DNS incident. And this is where the compromised IoT devices were used to using the DNS resolver to generate a massive DNS request targeting the authoritative DNS servers. This is the kind of different DNS defense techniques. Again, mitigating against DNS record types check. So we should be able to even look at the different type of DNS records and mitigate or rate limit or drop based on the DNS record types. Destination rate limiting. And the last two here, we talk about how we can leverage the machine learning, especially we'll talk about unsupervised machine learning to mitigate against zero-day attack. So the attackers are becoming more intelligent, and DNS attacks are becoming more sophisticated and automated. And we are talking here about how we can automate, and even the DNS defense system should be automated and sophisticated, so that here we have our multi-model or multi-level adaptive protection to mitigate. The main objective here, I see we have only 2 minutes or 1 minute before Q&A. But the main point here I wanted to make is how we can make this automated by minimizing the manual intervention during the wartime. And this is part of our threat intelligence system as a DNS-based defense solution, so that the more aggressive we apply on this from level 0 to level 4, we apply a more aggressive DNS policies to mitigate the DNS infrastructure. This should be my last slide, talking about, again, we talked about the DNS-based attack could be targeting. The victim could be DNS recursive or DNS authoritative. And we are seeing a lot of cloud providers, web giants, and other enterprises, as well as the service provider, have a lot of concern about protecting their DNS authoritative server. Because once the authoritative server are impacted, then the whole domain or applications are impacted. So here we're talking about additional capability on our threat defense or threat protection solution to act as authoritative DNS cache. So what does that mean? Basically, if the authoritative DNS server is under attack, we can scale up to 60 and 70 million DNS query per second by mitigating the down, as you can see here on the diagram, the authoritative DNS server, and the TBS will respond to these DNS queries by having the records on the TBS. Also, in addition to this, this is mainly during the wartime, and in addition to this, we can also integrate with the DDoS scrubbing solutions to make sure that the attacks are also cleaned at the scrubbing center or at the network internet edge. So I think we have, I don't know how many minutes we have for QA, or 3 minutes for Q&A.
We have some time for Q&A. So if anybody has questions, you want to come up to the microphone, line up and ask some questions. And also, do we have any questions online at the minute? No, if people online want to ask questions, just make sure you put the hashtag questions, plural, so we can filter them out. I was also thinking about buying an internet-connected broom I saw in the cartoon earlier.
Sure.
I might not do that anymore. Any questions coming in online? No? Anyone in the room? No? No questions in the room? Okay, then, Adil, thank you very much.
Thank you.
Thank you.
Thank you.